Yo guys, today we're gonna look at a past paper question which is testing a concept that is mostly left out in physics because honestly speaking it doesn't have a topic on its own. It's kind of like one of the tools that we use in physics, which is called derivation, and it's also testing our use of formula in order to manipulate problems, and I'm gonna show you how we do that right here. Okay, now let's get into it. So the question reads that pressure in car tires must be kept at a recommended pressure level. Tire pressure is monitored regularly so that the required action is taken if the pressure is not at the correct level. And the first question, or A1, uh, requires us to define pressure. So pressure is defined as the force acting normally per unit area, or you can say the force acting perpendicularly per unit area. Make sure you don't leave out normally or perpendicularly because it's going to disrupt the entire meaning. Okay, the second question is derive the SI unit for pressure. Okay, now let's talk about derivations right here. Okay, I think let me just switch the screen. Yo guys, so in this question we're being asked to derive the SI unit for pressure. Okay, we know that pressure is equal to force over area. So now here we're just going to substitute each of these for a unit of their quantity. Like for example, pressure is in Pascal, so therefore that's going to give us 1 Pascal is equal to force, which is 1 Newton, and area 1 meter, uh, 1 squared meter. And then here what we're going to do is that we're just going to divide them. So that's going to give us that 1 Pascal is equal to 1, right? Then this is going to give us 1 Newton, and then this m is going to be written as multiplied by 1 over m raised to the power of negative 2. So this is why we need to use our principles from exponents. So whenever we have 1 over something, this turns to a negative. Like for example, when we had x raised 1 over x, this is the same as saying x to the power negative 1. So we're saying that 1 Pascal is equal to 1 Newton meter negative 2, which is the same as just saying 1 Pascal is equal to 1 Newton per squared meter. And that's how you derive it. Okay, now let's proceed. The question, or part B of the question, reads Figure 5.1 shows an instrument used to measure or used for measuring pressure, which is a manometer. Okay, the atmospheric pressure acts at Z, and the gas pressure uh, to be measured acts at X. And the question is asking us to explain how the pressure at X compares with Roman 1, the pressure at Z. So we're comparing the pressure at X and the pressure at Z. So yeah, this is a point why I said we need to use our formula in order for us to manipulate certain questions or to answer the questions. So here let's just give the pressure for gas pressure at X. So gas pressure is equal to the atmospheric pressure plus the pressure which is as a result of the weight of the water column, H. Okay, now look at that, right? So we know that the pressure at Z is atmospheric pressure, and the gas pressure at X needs to be higher than the atmospheric pressure, because if they were equal, they would have been on the same level. And in this case, since the atmospheric pressure is higher, it means that the gas pressure has overcome the atmospheric pressure. Therefore, that's the reason why that the level of that arm is kind of higher than that at X. So now let's continue. The question further states that explain how the pressure at X compares with, and then for Roman 2, the pressure at Y. So the pressure at Y and the pressure at X are equal because whenever you have, liquids, the pressure at the same level is always equal. So yeah, that's that. Okay, now the question, or part C of the question, reads that the manometer liquid in figure 5.1 is water. Its density is 1000 kilograms per cubed meter. If the length from Z to Y, or the height of the water column, is 25 centimeters, determine the difference in pressure at X and that at Z. So another point where you need to manipulate your formula correctly. In most cases, people tend to plug in the values in the formula, but that's a wrong way of doing it. Okay, let me show what I mean. Let me just go to the next screen. Okay, this is just an example. It's not really part of the question. So it's telling us that if the pressure is 10 pascals and the surface area is 5 squared meter, find the force. Most people tend to say pressure is equal to force over area. Then they'll substitute the unit right here, and then they'll say 10 is equal to F over 5. Then they'll multiply the two, and that gives us F is equal to 50 newtons. Okay, even though the answer is correct, but this is not the right way of manipulating a formula. What you need to do, first of all, you need to make F the subject of the formula and say force is equal to pressure multiplied by area. Then you plug in the values, because that's how formula work. Even if you're looking at the quadratic formula, that's why it's called a formula. It's x is equal to something. That's how all formulas are supposed to be represented. And this is important in alignment with this question. So we know that we have a manometer, something like that, right? And then here we have x. I believe this point right here is supposed to be z, and then that point right there is supposed to be y. And we have already established the fact that the pressure at 2 points, which are the exact same level, is equal. So we know that at Z there's atmospheric pressure acting, and we also know that there's a pressure which is due to the height of this water column, which is right there. So the gas pressure is equal to the atmospheric pressure plus the pressure due to this water column. So the pressure due to a liquid is density multiplied by gravitational pull multiplied by height. If you want to know how to derive that, just pin pressure in liquids in the comments. Now, one thing that they're asking us to do is find the pressure difference between X and Z. And if you look at this carefully, they're asking us to find the pressure difference between the pressure of the gas and the pressure due to the atmosphere, or the atmospheric pressure. And if we look at this formula correctly, that's the pressure of the gas. Let's take the atmospheric pressure the other side. That's going to give us pressure of the atmosphere is equal to density GH. That's why you need to look at the formula before you plug in the equations, because this is what they want, the pressure difference between the gas pressure and the atmospheric pressure. So we just plug in the values. The density is 1000 multiplied by the gravitational acceleration, which is 10, multiplied by the height, which is 25 centimeters. But since that the density was in meters and the gravitational acceleration, is in meters per squared second, this is also supposed to be given in meters. And since this height is said to be 25 centimeters, since this is centi and it's a prefix which means 10 to the power negative 2, we can just say multiplied by 10 to the power negative 2. If we plug all this into a calculator, we're going to have 2,500 pascals. Yeah, and that's the correct way of using the formula in order to give you the answer. And also the correct answer. Well, that's all for now. Don't forget to like, subscribe, and share it with a friend. And also check out some other videos, success through synergy.
Jumped off quick, went straight in a free fall, cowboy